How's it going? This is our group. I'm Peter.
I'm Jessica.
I'm Mark.
I'm Tim.
So this is our clock mechanism. Right here, just to kind of go over it, we have our IV bags that are filled with water going through an IV system that is actually filling up kind of this awesome contraption. So what happens is water will fill up this top tube here, and then once that gets heavy enough, this whole thing will tilt, and there's a weight right here to correct it. And that whole process we've tried to measure to about 30 seconds.
That was one dump, and as you can see, it's just past 30 seconds.
So yeah, it's just past 30 seconds. We try to get the whole thing to dump and then correct itself at about 30 seconds. Kind of explain the parts of this. Our power source comes from the water, and then eventually the weight of the water within this tube. The escapement comes within the IV system here. This mechanism right here, you can screw in and out, and it'll tighten or loosen the pressure on the IV system.
That's 2 dumps, and that's 1 minute.
And that will slow down or speed up the flow of the water so that we can fill to the desired time. And the, what's the other one?
Regulator.
And the regulator is this whole seesaw mechanism. So it's the weight of the water compared to the weight of the actual weight. But it's kind of that system that becomes the regulator tilted on this axis right here. So that's kind of our clock in the system.
30 seconds.
So we're about halfway there. You guys see anything else?
Any funny stories about our clock?
Funny stories about our clock?
I don't know.
Just look at it.
Well, it took us a while to get the measurement right of all the duct tape and
Angle.
sticks. Yeah, the angles.
Shooting it into the pipe.
Yeah, the angles of the sticks and the duct tape is all very carefully measured up there. Also, how we've measured the milk carton and box.
2 minutes.
Oh, it's like right on. This is also very carefully measured. So,
Needless to say, there was a lot of trial and error.
Yeah.
yeah. But we finally got it right. It's starting to rain now, so we're trying to get through this. Let's see.
There we go, about 40 seconds left. Let's actually keep the time. There's 2 minutes and 30 seconds.
It's a blurry. You can see it.
Remember the last video too, so everyone was so bored of watching these things.
We made a pretty good lunch.
Yeah, lunch was delicious.
Kebabs.
Yeah, we're coming up on 3 minutes.
Why don't you, can you show the thing with the...
There's 3 minutes and 2 seconds.
So that's our clock. It took us a while to kind of figure it all out and get everything right.
Make sure that
but
the water was flowing at the right weight.
yeah, usually what would happen is the box would move because it's not exactly the most stable thing in the right area. Or sometimes the sticks and duct tape wouldn't really work. But once we got it right, it works pretty well, so that's our clock. One more.
Okay, so this is our second clock that we made out of a bunch of junk that we just had lying around. And I'll start the timer, talk about it as it goes. Okay, and start. So idea is it just works on the weight, the falling weight here, and it provides some torque to the center balance that is regulated by the wrapping of the string on both sides and its counterweight. Yes, this is the weight and the driving force here. This is the escapement, and the regulator is just based on the natural wrapping and unwrapping of this weight on both sides. And the readout is based on this string here. When 1 minute comes by, and at each 1 minute intervals, there'll be a black mark that passes through there. It is prone to a little bit of irregularity because of the friction, and to put it politely. because of the friction between this tube and the surface here. And once it does that, it does tend to set itself at the correct rate again, but it takes a while. So that was 1 minute that just went by and I wasn't paying attention. And it's off by about 1 or 2 seconds. So it should even out over the long run as long as the error doesn't start to compound and create greater errors. But I don't know, this is just a simple design, something you could actually make out of a bunch of junk like we talked about in class. That's about it. Now we can just kill time and see if it actually works for the other 2 minutes. As you can see, it doesn't wrap exactly the same time every time, but like that one. But it tends to balance out fairly well in the long run. It actually took a lot of trial and error to get it to work correctly with changing the weights, the weight at the end, and the circumference or radius of the arm here. Okay, that's our second mark coming up at 2 minutes. That's right about dead on.
Wait, let me see.
There you go. There we go. 2 minutes and 4 seconds just passed. Oh, see, I've lost a little momentum there. But hopefully it wraps more on the other side because of it, and it should work itself out again, as long as it doesn't get several in a row. So I don't think you'd want to navigate with this clock, but that's fairly interesting. This is called the flying pendulum. And our first models had only a single string holding the weight, but it fell too quickly to the ground, so we had to make this little complex pulley system here so that the weight fell at a slower interval. So now we're getting a little bit of a difficulty up there, and we're off by about 10 seconds on that black mark because it went a little bit too fast. But still within the error that we set for this. That's about it.